One more time on page 5.
545.
Yes?
Number 25.
25. Very good. We're asked to find sine 37 multiplied by cosecant 37 degrees. So now I'm asked to determine this product. Sine cannot be written in a simpler way than sine. Sine and cosine cannot be written easier than that. Okay, but cosecant has a formula. So if it starts with C, is 1 over sine 37. Well, these two numbers must be the same. Please write the 1, because I don't want you to conclude that this is 0. So the answer is 1. Very good. Anything else?
We do number 31 on 529.
529, number, you said 29?
31.
31, I'm sorry. 31. On 529. Very good. So we have negative 40 degrees, and we're asked, it says, convert each angle in degrees to radians. Good. So here's what I would like you to just think about. I know you know it. If I say I have $90, it means I have 90 multiplied by $1. Would you agree? So negative 40 degrees means negative 40 multiplied by 1 degree. Or 50 meters is 50 multiplied by 1 meter, right? I know what this means because I know the relationship 180 degrees equals pi, which means 180 multiplied by 1 degree equals pi, which I will get 1 degree by doing what to both sides? Both sides by? Very good. So all I have to do is just put it in here. You don't need to memorize this, but you do need to remember that. Yes, without that we cannot proceed. So then I would have negative 40 multiplied by pi divided by 180. And as you see, I talk too much. I did not prepare my calculator. So I have to multiply negative 40 by pi and divide by 180. I don't have to put the negative in there because it's clear. 40 multiplied by pi and divide the answer by 180. And I know it's going to be a negative number because so it's negative 0.6981 approximately. So approximately negative 0.6981. Is this clear? Okay, very good. Anything else? Anything else you worked on? Anything else you want to go back to?
You also do number 61 on the same page.
Yes. 61 on the same page. 61, where are you? 61. Yes. Find a positive angle less than 360 degrees, or 2 pi, that is coterminal with a given angle. Excellent. Negative 655 degrees. Perfect. I personally prefer to see the angle. It may not be necessary. You may say, well, I can find it without presenting the angle. That's true too. But here's what I would do. So I know that this is a negative angle, so it has to go clockwise. I know that this is negative 360, and another complete rotation will give us negative 720. So negative 765 is negative 720 degrees minus 45 degrees, right? So negative 765 is composed of negative 720, which means 2 complete rotations, and another, I will continue, 45 more. But 45 more is exactly in the middle. So So this is the angle that represents negative 765. All this. So I don't want to put, maybe I should put it in there like so you can see it. Good. So now I'm asked to find, it says find a positive angle less than 360. Okay, in order to find a positive angle, then I have to go counterclockwise, and the angle has to start at the same point, same initial side, and it has to end at the same point, which is the same terminal side. Well, I know that this is 360, the whole thing is 360, but I have to come back 45. So it will start at 0 and it will end here. So 360 minus 45, very good, 315. And that is the positive angle less than 360 degrees, coterminal with negative 765. I prefer to see it. It's easier for me, but you can say, oh, why subtract this? No, it must be that. That's fine too, but I recommend presenting the angle first. Good, very good questions. Anything else? Anything else? Okay, what I would like to do, go back to for a moment, the most important trig identity that we discussed last time. First, it's also called Pythagorean, if you want, first trig identity that we looked at. Can anyone give us what that was? Of beta, very good, plus of the same angle equals 1. Two other identities are obtained from this one. Please divide both sides by cosine squared theta and tell me what you get. When you divide sine squared by cosine squared, of the same angle, of course, what do you get?
Sine squared theta.
Over cosine squared beta. What is that? What is sine over cosine? Tangent. So then we get tangent squared beta plus. How much is cosine squared over cosine squared? Very good. Equals. How much is 1 over cosine squared? There is a trig function that has 1 over cosine. It starts with c in the denominators, secant squared. Oops. I meant the same angle, of course, beta. So, I'm sorry? Oh, it has to be the same angle. Whatever you use. You can say tangent squared a plus 1 equals secant squared a, as long as it's the same angle. Good. Now the same first identity, please divide it both sides by sine squared now. Sine squared beta, of course. Tell me what you get. How much is sine squared beta over sine squared beta? Plus, how much is cosine squared beta over sine squared beta? And that is a trig function. Secant is 1 over. So it's cosine over sine. Sine over cosine is tangent. Cosine over sine is cotangent. Square beta equals 1 divided by sine squared is 1 over something that starts with s. If it starts with s in the denominator, cosecant. So this is the second one that is derived from the most important one, from the basic one. And this is the first one that is derived from there. Any questions? Any questions? Any questions? Okay, so this one is the most important one, and these are 2 and 3. You can we can say 2 and 3 or 3 and 2. It doesn't matter. Both of them are a result of the most important one. I would like to go back to a right triangle whose acute angle is alpha. Can anyone say anything about this angle? What should this equal to? And I'm going to say that this is 90 degrees or pi over 2. And this is alpha. What should this equal to? Say it again. No, you can't say that. You can't say that either. We know that the sum of all angles in a triangle is, so this plus this must be 180. Do you all agree? Okay. Then if this is already 90 degrees, the sum of these two must equal 90. So then this angle must be 90 minus if this plus this is pi over 2, then this must be pi over 2 minus alpha, indeed. You agree? Right? So if this is pi over 2, the sum of these two has to be pi. When you add pi over 2 minus alpha to alpha, you get another pi over 2. Would you agree? Okay, very good. I am going to denote the sides by some letters. I'm going to say A, B, and C. So the measure of the opposite leg is A, the measure of alpha. The measure of the adjacent is B, and the measure of the hypotenuse is C. And I'm going to ask you two things. To find sine alpha for me, four things, I'm sorry. Cosine alpha, and then I would like you to find sine pi over 2 minus alpha, and then cosine pi over 2 minus alpha. We have the sides. Let's establish what sine alpha is. Opposite. Oh, good. So please give me the ratio. A over. Excellent. Can anyone give us cosine alpha? Excellent. Now I'm looking at a totally different angle. I'm looking at this angle, and I would like to determine the sine and cosine for this angle. Disregard alpha. I don't care for alpha right now. I want to find sine of this angle. Do you all agree with B over C? Opposite over the hypotenuse. Now I want cosine of the same angle. Good. Look at this. So we notice that sine pi over 2 minus alpha equals the cofunction of alpha. What cofunction of alpha? Now, can anyone give us cosine pi over 2 minus alpha? What does that mean? It's the cofunction of cosine, which is sine alpha. In the same way, let's find the pattern. And these are so-called cofunction identities. If I were to ask you, let's say, tangent of pi over 2 minus alpha, what will you say? What do you think? Just a wild guess. Tangent of pi over 2 minus alpha is the cofunction of tangent, which is cotangent alpha. Now, what if I ask you cotangent pi over 2 minus alpha? What will you say? Very good. What if I ask you secant pi over 2 minus alpha? Cosecant alpha. And the last one, what is the last one that I didn't ask yet? And what will be the answer? Very good. So I would like to look at, find a cofunction with the same value as the given expression. So I would like to look at 31, sine 7 degrees, and I will also like to look at 33. They're both recommended, and we can choose any problem other than these that you want to work on. So sine 7 degrees will be the same with Yes? Cosine of 90 minus 7.
So 60
90 minus 7,
is
83. Cosecant 25 degrees will be the same with, excellent, of, you don't need parentheses. I don't know why I put parentheses. So secant of, of course,
Okay, so 65.
65 degrees. Okay, use a calculator to find the value of a trig function. I don't find that useful at all, but let's look at, because you just plug it in, but let's do it because I want you to see it. Tangent 32.7 and also, let's say 45 cosine pi over 10. You have to be very careful how you put it in. If you're given degrees, like we have in tangent 32.7, make sure that the mode, please click on the mode is in degrees. So where you see radians and degrees, scroll down, move to the right, press enter on the degrees. So now we are ready to punch in degrees. So then I go to cosine. No, it wasn't cosine, it was tangent, I'm sorry. Tangent 32.5 and press enter. And I get, it says with 4 decimal places. Okay, so 0.6371, approximately 0.6371. Now for cosine pi over 10, I have to go back to the mode. I have to change the mode to radian. Click enter. And then I have cosine. I have to put pi. Here's pi right here with the caret. And divide by 10, I think 10, yes, 10. And then close the parentheses and press enter. So the answer is 0.9511, approximately 0.9511. Okay. I like to look at a couple of word problems here, like 73 on page 546. I'm just copying the right triangle, and we are given 40 degrees, and we are given 630 yards, and it's denoted by A, B, and C. Okay, let's read the question. To find the distance across a lake, a surveyor took the measurements shown in the figure. And by the way, that's how they determine them. And you see those people on the road, on the side of the road, they're taking measures, they measure angles. Yeah. Use these measurements to determine how far it is across the lake. Round it to the nearest yard. Okay. So I have this length and I have 40 degrees. So I'm interested in this. So that's what they're asking us to determine. A. How do I do that? Knowing trigonometry. And knowing this angle and this side. I want to find the trig function that I will apply to determine this side. Very good. That's all I need. Why? Because tangent of 40 degrees is a ratio. Which ratio? A over 630 yards. So in this case, the tangent function allowed us in a moment to determine A. Good. So now remember, this is a proportion. What do we do in a proportion? Always. And only, yes, exactly. We will cross multiply. So I'll multiply these two. So A times 1 is A. And this times this. Do not put 630 behind 40 degrees. Please put the number in front and then tangent follows. Because when you punch in the calculator, you may put parentheses, who knows what happens, and you consider 40 degrees times 630. And so I have 630 multiplied by tangent, and tangent is in 40 degrees, and that would be a terrible mistake if I would press enter. Why? Because my mode is in radians. So I have to go back and change the mode back to degrees, and then press enter, and that will be fine. So to the nearest yard, 529 yards. So A equals 529 yards. Okay. I would like to look at one more. Let's say 79. Or I like 77, but they didn't pick it, so I'm going to do the recommended 79, or you can choose. We can do both. A telephone pole is 60 feet tall, so we are told that. One of the workshops that I enjoyed very much at this conference that I told you about was one professor would make the entire, almost, I shouldn't say entire class, but he would present a lot of videos or movies, small pieces, few minutes of a piece of a movie or YouTube or whatever, and he would ask the students, what do you think, what part of math that we discussed so far is discussed here or is presented here? And you know, the characters in the movie, sometimes they just come up with some crazy answer that has nothing to do with the reality, and the students would be asked to correct the mistake presented in that particular movie. So for example, there was one person, I don't remember which movie he presented because there were so many, I wrote it down, but one character came in and said, oh, I threw this 30 feet. What do you mean 30 feet? I'm not 30 feet tall, tall. So how? So they had to present whatever. They had to come up with a function. It was very nice, very interesting. I wish I had the time to do at least one or two of this. Okay, so we're asked to determine. It says a telephone pole is 60 feet tall. A guy wire is 75 feet. Is attached to the ground from the ground to the top of the pole. Find the angle between the wire and the pole to the nearest degree. So, you want to apply a particular trig function. Which one? So, I have the adjacent and I have the hypotenuse. Cosine. Good. So, cosine theta equals 60 divided by 75 degrees. 60 feet divided by 75. I have to determine that. So, let's say I get 60. I'm just dividing to make a point. I shouldn't, because we can do it in one step, but I just want to make a point. 60 divided by 75, I got 0.8. So the cosine theta equals 0.8. So I'm asked to find theta. I'm not asked to find the cosine of theta. I'm asked to find theta. So now let's have a little chat. Here's our little chat. If I want to solve the equation the square root of x equals 2, what should I do to both sides? Why? Because the square root and something squared are what type of operations? Excellent. So now I have to find a way of applying the inverse operation of cosine. Now remember also when we said, I don't know, e to the x equals 4. What did we do with this? Yes, why did I apply natural log to both sides? Because e to the x and natural log x are inverses of each other. The same thing here. The function that is inverse of cosine is denoted by cosine inverse, as we expected. So then cosine inverse is applied to both sides. So I apply cosine inverse to this side, and I apply cosine inverse to this side. But what will happen when I apply cosine inverse to cosine, or cosine to cosine inverse? What will those functions do? Exactly. They will cancel their effect on x. So then what am I left with on the left-hand side? Exactly. So then this is how I find theta as being cosine inverse of 0.8. Remember, this is not 1 over cosine. This is the function called inverse of cosine. So here it is in blue. On my software in blue, in yours maybe in yellow, right here. As you see, the square root and x squared are inverse functions. Both are on the same key. 10 to the x and log are both on the same key. E to the x and ln, both on the same key. The same thing with sine and sine inverse. The same thing with cosine and cosine inverse. And the same thing with tangent and tangent inverse. So now I know my mode is in degrees. So I go to second and cosine. And what do I put in parentheses? What do I put in parentheses? Very good. Sorry, I didn't hear. You probably said it. Good. I expect the answer to be in degrees. And it is roughly 37 degrees. So theta here is approximately 37 degrees. Any questions? Any questions? Okay. I would like to continue. It's more of the same thing, nothing new, just different types of problems. I'm on page 560, and this is 5.3 trig functions of any angle. 5.3 trigonometric functions of any angle. Okay. A point on the terminal side of angle theta is given. I'm looking at the first set. I'm doing problems from each set. Recommended. So the first set on page 560, from 1 through 8. So page 560. Okay, let's say problem 3 on that page. And the point is 2, 3. And we're asked, find the exact value of each of the 6 trig functions of theta. Oh, okay. First of all, in the Cartesian system, this is of course my x, this is my 0, my origin, and this is my y. Where will I plot this point? Which quadrant? Yes, 1, 2, 3, okay, 1, 2, and 3, right here. So the point 2, 3, 2 for x, 3 for y. I form a right triangle. This is a right triangle. Can anyone tell us how much is this piece? Very good. Can anyone tell us how much is this piece? Good. Can anyone tell us how much is this piece? Yeah, and you can say, wait a minute, give me a second, I need to apply the Pythagorean Theorem and I'll tell you what it is. So I'm going to call it for now Z. Can anyone give us the Pythagorean Theorem in this triangle? Z squared equals 3 squared plus 2 squared. 3 squared is 9, 2 squared is 4. It turns out that this Z squared is 13. But I don't want Z squared. And I know that Z is a distance from this point to this point, so it has to be a positive number. But what do I do to both sides to get Z? I take the square root, and correct, I should write this. But then I'll say, no, only Z equals the square root of 13. Now I have the length of the legs and the hypotenuse. I only need 30 seconds to write 6 trig functions, right? Okay, I'm ready for the sine, and this is the angle we are talking about, alpha, right here, between the hypotenuse and the adjacent. So sine alpha, cosine alpha, that's all I need, because the rest I know how to find them. I don't need the triangle anymore. Once I have sine and cosine, I have the other 4. Can anyone dictate sine?
Sine is 3.
Very good. And how much is cosine?
2.
Now I don't need this anymore. I don't care for it. because I know the tangent is this over this, and when I flip it, I get 3 over 2, and I simplify the square root, right? 3 over the square root of 13 divided by 2 over the square root of 13. This is 3 the square root of 13 times the square root of 13 divided by 2. So I get 3 halves. I know cotangent, because I know it's 1 over tangent. 1 over tangent. So what is cotangent? Right, which is 2/3. I know secant alpha, which is 1 over, right, so it's the square root of 13 over 2. And then I know cosecant alpha, which is 1 over, so it's the square root of 13 over 3. I only need 30 seconds. Please choose another problem so we can work on this one more time. But please tell me if you have questions. Please choose any problem from 1 through 8 so we can redo this with a different example. Which one? 8 it is. So let's do 8. I'm sure he doesn't even have a book. No, he has a book. Just kidding, just kidding, just kidding. Okay, 8. -1, -3. I have to picture this. Can you please tell me which quadrant will have -1, -3? Good. So -1, 1, 2, 3. Right here. This is the point. This is the angle, actually. But of course, we are going to look at the reference angle. So this and this. So we're looking at this, in other words. So can anyone tell us this distance? Careful. Right. For x and y, I can have negative numbers, but for z, I cannot have negative numbers. Bless you. Can anyone give us this distance? Good. Well, of course, I need z. Careful. Z squared equals -3 squared plus -2 squared.
Your x distance.
No, it's -1, not -2.
Oh. Can get away with anything in this class. Sorry about that. You're right. I'm sorry. So z squared equals 9 plus 1. So then z squared equals 10. I take the square root. Z equals plus or minus. I'll say no way. Z equals the square root of 10. So then this piece is the square root of 10. Now I have to be careful because in the third quadrant, sine and cosine will be negative. Good. So I'm ready when you are. Again, it will take us 30 seconds to write these 6 trig functions. Yes?
So would the z be the negative square root of 10?
No, the distance is distance.
Okay.
Yes, x and y can be. So I can, to show direction, I can get to you from -2 or -3 and -1, but this distance is still a positive distance. I cannot say the distance between me and you is -5p. Very good question, actually.
Right.
Okay, so sine alpha, alpha being this, cosine alpha, tangent alpha, cotangent alpha, secant alpha, cosecant alpha. 1 minute, please work on this and tell me the answer. I'm taking my attendance.